Okay, in this video, we'll look at some of the homework problems in section 7.3. We'll start with problem number 1, where you're finding a decimal representation of 1/9. And the way that we can do this is through long division by dividing 9 into 1. Okay, and here I'll put a decimal point behind the 1 and then in the quotient and then added 2 zeros here to find out what type of pattern I'm going to have. So if I divide 9 into 10, I'm going to get, it'll go one time. 1 times 9 would be 9. 9 from 1, 9 from 10 will give us 1. Bring down to 0. 9 goes into 10 one time. 1 times 9 will be 9. From 10 we give 1. And if I continue this pattern of dividing 9 into 10, I'm going to get 1 each time. So I know that the 1 repeats. So 0.111, and it's repeating, would be 0.1. Now, the way we write this with a bar on top to show that the 1 repeats. Okay? So here our answer would be answer D, 0.1 with the bar on top showing that only the 1 repeats. Problem number 2, we're going to convert this repeating decimal to the form a over b, where a and b are integers and b is not equal to 0. In this case here, we got 3.81. And as you can see here, the 8 and the 1 repeats. Okay, so here. Now, what I'm going to do here, the way I'm going to set up this particular problem is this. N is going to be the 3.8181 ... That's another way of writing this number 3.81 to show that it does repeat. 2 of these numbers repeat, the 8 and the 1. So I'm going to take this equation and multiply both sides by 100. So if I multiply 100 times n, I'm going to get 100n. That's going to be equal to, and if I multiply this by 100, I'm going to move this decimal point 2 places to the right, so it'll be 381.8181 ... showing that it repeats. And then I'm going to subtract these two equations together. Okay? Now, when I subtract 100n minus 1n, that's going to be 99n. Now, on the right side, the repeating part is going to cancel. You're going to have 381 minus 3, which is going to be 378. So we got 99n is equal to 378. And then you're going to divide both sides by 99, which means n is equal to 378 over 99, 378 over 99. And then, if I reduce this by dividing the numerator and the denominator by 9, that means 378 divided by 9 in this case will be 42, over 99 divided by 9 will be 11. So 42 11ths will be the fraction in simplest form. And we will leave this in the form a over b, which is in this case an improper fraction. Okay. Problem number 3. Okay, now I'll take a look at this one. We're going to order these repeating decimals. Some of them are repeating because of the bar on top from least to greatest, and those are the numbers here. And what makes it more complicated that these are negative numbers here. And we're doing this from greatest to least, which means we have to look at the smallest number. The smaller of the two, or the smaller, will be the one that's closest to 0. So we got negative 4.898, where the 898 repeats. I'm going to expand that as negative 4.898, 898, 898, ... is only the 8, the 9, and the 8 repeats. Then for this one, where only the 9 and the 8 repeat, so we have negative 4.8. Then you have 9, 8, 9, 8, 9, 8, 9, 8, dot, dot, dot. And then for this one, only the second 8 repeats. So we got negative 4.8, 9. And then the 8 repeats, so we just have 8, 8, 8, 8, 8, 8, 8. And it continues. Then the last one is negative 4.898. Now, if you want to put zeros there, that's fine, because that one's the terminating decimal. Okay, now we're going to compare place value positions until you come to the place value position where their face values are different. The 4s are the same, the 8s are the same, the 9s are the same, the 8s are the same. But when you get here, they start changing. We want to use the smallest of the two, of the 4. The smallest is the one that's closer to 0, and that's this one right here. The 0 goes to the negative 4.898. Okay, so that's the greatest. And then it's going to be between the first and the third. Start looking at the next place value position to the right. You'll see that there is a difference. This is smaller than this. This one is closer to 0 than the first one. So that's the second one. This will be third. And this will have to be fourth. Okay, so to put this in order, negative 4.898, that's first. Negative 4.898, where only the 8 repeats. And then the third one is negative 4.898, where the 8, 9, and the 8 repeats. And then the last one is negative 4.898, where only the 9 and the 8 repeats. So here is answer B. Okay, number 4. Find 3 decimals between each of the following decimals. In part A, you get 6.88 and 6.8 repeating. So think of this, 6.8, 8. Now 6.8 repeating is 6.8, 8, and it goes on and on and on. So we want to select from this set which one of these are between 6.88 and 6.88888 repeating. Well, by looking at this, I'm thinking, is this one. 6.887 is between 6.88 and 6.888 repeating, so it's 6.886 and 6.885. So I choose that one. Okay? Because you can think of this with the zeros, and then this has 8s going on in forever. And then part B, 3 numbers between 155.279 and 155.27, where the 2 and the 7 repeats. Okay, let's see, 155.279, 155.2727, and it goes on and on and on. I know this is bigger than this, by the way, so we want to find some 3 numbers that are in between those. So in this case here, I'm looking at, let's see, 2728, that's in between these two. 155.2729 and 155.2730. Those are in between these two. Because you can add a 0 if you want to. You'll see that those numbers are in between those two. Okay, number 5. Find 3 rational numbers between 1/4 and 0.25 repeating. I know 1/4 as a decimal. If you do 1 divided by 4, that would be 0.25. and 0.25 repeating is 0.25, 25, 25, continuing. I'm putting zeros here. Okay, now you're going to select the ones that are between 0.25 and 0.2525. Well, by looking at this, well, I see 0.2511 is in between those two, so we'll use that one. 0.2546 is not in between those two. 0.2514 is a candidate. It's in between those two. Let's see. 0.258 would not be in between those. 0.2510 is. And 0.0025 is not in between these two. In fact, it's less than 0.25. Okay? So the ones that I have checked are the ones that are in between 1/4 and 0.25 repeating. Okay, part B. Which ones are between 1/9 and 0.12 repeating? I know 1/9 is 0.1111 repeating, and 0.12 is 0.121212 continuing. So we need numbers in between these. Let's see, 0.1148 would be in between 0.1111 and 0.1212. 0.1123 is another number that would be between those two. 0.1132 would also be in between those two numbers. Now 0.1101 is not, because that's less than 0.1111. 0.8173 is definitely not in between those two. It's bigger than 0.1212, and then 0.0012 would not be in between, because that's less than 0.1111. So it's these three that I have checked. Problem number 6. Use the fact that 0.1 repeating is equal to 1/9 to convert each of the following into fractions. In this case, you got 0.6 repeating. In this case here, we're using the fact that 0.1 is going to be 1/9, so that means that 0.6 will be this number over 9, so it'll be 6 over 9. And if you reduce that, it will be 2/3. So 0.6 repeating as a fraction is 2/3 in simplest form. And then 3.8 where the 8 repeats. In this case here, using the fact that 0.1 repeating is 1/9, this will be 3, and the 8 will be on top, and 9 will be on the bottom. Now they want this as a integer, a proper fraction, or a mixed fraction, a mixed number. So as a mixed number, it will be 38/9. I mean 3 8/9. Okay. Problem number 7. Use the fact that 0.01 repeating is equal to 1 over 99 and 0.001 repeating is 1 over 999 to convert each of the following into fractions. In this case here, 0.12 repeating, where the 1 and the 2 repeats, the 1 and the 2 goes on top. The two numbers that repeat, that means we use the 99. So it'll be 12 over 99. We're going to reduce that by dividing the numerator and the denominator by 3. You'll get 4 over 33. Okay, so 0.12 repeating as a fraction would be 4/33. And then you got 7.945 where the 9, 4, and the 5 repeat. We know we got 7, and then 945 will be on top. The fact that 0.001 is the same as 1 over 99, 945 will be 945 over 999. Okay, now we need to come up with a number that's in simplest form. So 945 over 999 in simplest form would be, by the way, I'm using calculator for this one, 35 over 37. So this will be 7 and 35 over 37. And they want a simplified fraction. So if you were to convert that as a mixed number, it would be 294 over 37. Because you'll have to do 37 times 7 and then add 35 to it to get the 294 over 37. Okay. And finally, problem number 8. You're going to use the formula to find the sum of an infinite geometric infinite geometric series. You're going to use that formula to find a rational number in the form of a over b, where a and b are integers and b is not equal to 0 for the following repeating decimals. In this case here in part A, you got 0.65, but only the 5 repeats. Okay, and I'm going to do this one. 0.65, but only the 5 repeats. Okay, now in this case here, we're going to do this. Since we know one number does not repeat, let's go ahead and multiply by 10. So we're going to have 10n is equal to, now if I multiply this by 10, I'm going to move the decimal point one place to the right, so it'll be 6.5, and we know the 5 repeats. Okay? Now we have one number under the bar that repeats. So let's multiply that by 10. This equation we're going to multiply by 10. So if I multiply 10 times 10n, I'm going to get 100n. And if I multiply 6.555 repeating by 10, this will move the decimal point one place to the right, so it'll be 65.555 repeating. And then I'm going to subtract these two off. The repeating part is gone. 65 minus 6 will be 59. And then 100n minus 10n will give me 90n. So I got 90n is equal to 59. Then we divide both sides by 90. That means n is going to equal to 59 over 90. So 59 over 90 is the fraction for this decimal in simplest form. Okay. Now part B, we got 3.065, but only the 6 and the 5 repeats. Okay, the part that doesn't repeat is the 0. So we're going to multiply this decimal by 10. So we're going to have 10 times n is equal to, now if I multiply this by 10, I move the decimal point one place to the right, so it'll be 30.65, 65, and so on. But notice the 6 and the 5 repeats. So this equation needs to be multiplied on both sides by 100 because two numbers repeat. 10n multiplied by 100 will be 1,000n. This 30.6565 repeating multiplied by 100 means I move the decimal point two places to the right, so it'll be 3065.6565. Continues on. Now I'm going to subtract the two equations. 1,000n minus 10n is 990n. On the right side, the repeating part is canceled, is gone. So 306.5 minus 30 will be 270. Take that back. 3065 minus 30 would be 3035. Okay, let me check my subtraction because I could be wrong. 3065 minus 30 is 3035. Okay, so I have 990n is equal to 3035. Divide both sides by 990. I'm going to get n is equal to 3035 over 990. And of course, we'll have to put this in simplest form. And in this case, it will be, it'll end up being 3 and 13 over 198. But I'm sure they will want this as an improper fraction. It will be 607 over 198. Okay. Okay. So here, be very careful when you type in your answers because they do sometimes want it as a simplified fraction, so you have to write it as an improper fraction. And that should assist you with the homework problems in section 7.3.